Suppose this is head, and you are tossing 3 coins.
Yeah.
So number of head, tail, 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 head, tail, head, tail. So it may be zero number of head, one number of head, two number of head, and max to max three number of heads, right? And
Yeah.
the probability of getting zero number of head is zero number of head means all are tail.
Yeah. Yeah.
So there is only one possibility which gives all are tail, one out of eight, right? This is
Yes.
one number of head. One number of head lies one, two, and three possibility, right?
Yeah.
Two number of head, one, two, three possibility, right?
Yes.
And three number of head means all are head.
One. All right. Yeah.
Okay. So the this table is called distribution function.
What do you call it? Excuse me.
Distribution function. This function.
Distribution function. Okay. Oh, okay.
Okay. The combination of head and its probability is called distribution function.
So, and the summation of these probabilities is going to be like one, right?
Yes, it is always equal to one. Okay. So this is distribution function. Sometimes this is called probability distribution function. Okay.
Okay. So,
PDF, probability distribution function.
yeah. Okay.
Okay.
I hear PDF, but I didn't know it's simple as much as this.
Yes, yes. So this is called PDF. Okay. Sometimes it is represented by f of here h is variable, so you can replace f of h. Okay. You can
Yes.
also write in this way: f of h is 1 upon h when h is equal to 0, right? It is 3 upon 8
I see.
when h is equal to 1. 3
So
over 8,
you formulate it as a function.
yes. And it is 1 over 8, otherwise 0. Okay.
Thank you.
Okay. So writing in this way, you can also write in table form. Okay. Understood? The table form can also be written as function form. Right? Okay. You can also note this function as what? Let's suppose this is t. 1, 2. So there are basically three random variables. Okay. The probability of getting at 0 is 1 over 4. 1 over 2, 1 over 4. When you add all these probability, you will get always 1. This is very important. This is
Summation.
summation of all probability, always equal to 1. Okay, right?
Yes, sir.
In this case, when you add all these, 1 over 8, 3 over 8, so 3 plus 3, 6 plus 2, 8 over 8, that is 1, right? Summation of
Yes.
probability is equal to 1. Very important result. Understood?
And we consider H
H is a random
as
variable.
random
Yes. Here H represents what? Number of head on throwing three coins. Okay. And the whole system is called probability function. Sorry, distribution function.
distribution.
Okay. When a random variable comes with its probability, then this is called distribution function. Okay.
Yeah.
Okay. Same thing I told you. Probability density function. PDF probability, you can say density function or distribution function. Both are same thing. Okay.
Mm.
See, there are basically two things. One is discrete thing, discrete random variable. Second is continuous random variable. What is discrete? Discrete is a thing which can be counted. Discrete value, right?
Yes.
For example, number of man, number of city, number of coins, right? And continuous random variable which cannot be counted. It only measures, cannot be counted. Measure means height, weight, age, right?
I see.
Height cannot be counted, right? Height can be measured. Weight, right?
Yes. Yeah.
Age, okay? These are considered as continuous random variables. Can you count height? No, you can measure only,
Can measure this.
right? Number of coins, these are discrete value. Number of dice, number of person, anything which can be counted as considered as discrete value, right?
Yeah, that's right.
Yes. In discrete value, the distribution function is represented by table. It is represented by a table in tabular form, and sum of all probability is equal to 1, right? But in continuous
Yes.
random variable, it is represented by a function, and the sum of all integral means minus infinity to plus infinity fx dx is equal to 1. Okay. In
Yeah.
continuous, integration is used. In discrete, table is used. Summation is used.
So in that case, this function that we will do the integration for minus
Minus infinity means smallest value of t and plus infinity largest value of t.
I
Let's
see.
suppose x is going from 1 to 2. So this is minus infinity and this is plus infinity. So you can write 1 to 2. Okay. It will equal to 1.
I see.
Right.
And that's great. Yeah,
Minus infinity represents smallest value.
I see.
Okay. The range of x.
Yeah.
Right. So these are
Yes.
very important things you must know.
So very important. Yeah, these are the now you are trying, how can I say? You are connecting the concepts in my mind. What I mean, like I have everything like all these concepts, but I don't know the relationship with them. Like, for example, now when you said like the integration of continuous probability is going to be equal to 1.
Yes.
So I see the relationship.
Always remember whenever continuous random variable comes, probability density function comes in the form of a function. And whenever discrete random variable comes, its density function comes in the form of tabular form.
Okay.
Okay. Because each
Yes.
random variable has its own discrete value.
Mhm.
Right? You can see which type of function is this?
This is it's continuous.
Continuous.
We have,
Yes.
yeah.
Okay. But same thing if I give like this. 1 when x is equal to 1, 2 when x is equal to 2, 3 when x is equal to 3. Then you can
This is
say
type.
yes, because x has only 3 discrete values. So you can write in this way. This is random variable x. X is equal to 1, x is equal to 2, x is equal to 3. Let's suppose this is uh, 1 over 3, 2 over 3, 3 over 3, right? Its probability is 1 over 3, 1 over 3, sorry, 2 over 3, 3 over 3, right? So this is what? Discrete. But why this is continuous? Because x goes from 0 to 3 continuously. Because you know between 0 to 3 there are infinite numbers,
Right.
right? From 0 to 3 there are infinite numbers. 2.9, 2.5, 1.33, any, it can be anything, right? But discrete value is always fixed, right?
Yes.
So this is a continuous random variable. I think you get clear.
Yes.
Okay.
Yeah. Thank you.
So verify fx is a PDF. So first you have to prove that this is a continuous random variable. So how can you prove? It's very easy. Whenever you are given a function and you are asked to verify that the function is a PDF. PDF means probability density function. So first of all, you have to check that from minus infinity to plus infinity, fx dx is always equal to 1. Okay.
Mm-hmm.
So here minus infinity means what? 0. And plus infinity is what? 3. Right?
Okay. Okay.
Yes. And fx is what? 1 over 9 x square dx. Let's see whether it gives 1 or not. If it is not giving 1, then this is not a PDF. Okay.
Yes.
Okay. 1 by 9 is a constant.
Right. X to the power 3.
Yes. X to the power 3 over 3 from 0 to 3. 1 over 27. 3 over 3 0. Right? 3 over 3 is
Yes.
27. You are getting one?
21. Yes.
Yes.
That.
So here you can say, and you can ask, sir, what about this? You can leave this because the function, the value of this function is 0.
It's not yet.
Okay. If the value of function is 0, then don't take it.
I see.
So you can see
How about if it was like, how about if it was like, for example, 7, not 0?
if
Should
it
we take
was
it into
7,
consideration?
if it was 7, right?
Yeah.
Okay, I tell you. First I see this 0 to
Yeah.
infinity fx dx is equal to 1. So you can say fx is a PDF. Okay.
With the distribution function.
Okay. Now you are asking that 1 over 9 x square. Let's suppose this is 7x and this is less than 1. Okay. And 0 otherwise, right?
Yeah.
Okay. So what you can do? You can do this represents what? Less than 0. Less than 0 means what?
It's like negative values.
Negative infinity to 1, right?
Not yet.
Yeah, this is 0. Less than 0 means what? From negative infinity to 0. Sorry. Okay.
Yes.
Sorry, not less than 0, less than 1. My mistake. So you can write minus infinity to 1, right?
Yeah, stopping at that one. Yeah.
Yes. So you can write here 7x dx. Now this is from 0 to 3 is equal to 1. Okay. Understood?
Yes.
Okay. Now if fx is a PDF, find the value of probability from x is greater than 2. Okay. You have already verified that this is a PDF. If it is not a PDF, then you cannot find the probability. First of all, you are always asked to find the verify the this is PDF. If it is PDF, then next question will be how to find the probability. It shows what? Probability of x greater than or equal to 2, right? Okay. So how can you find x? Limit of x is goes from 2, right?
Mm-hmm.
It means what?
Infinity.
Yes, to the infinity, right? Fx
Mm-hmm.
dx. So from 2 to infinity, fx is what? 1 over 9, x cube over 3, right?
Mm-hmm.
Okay, okay. One,
And
one, one more important thing. You cannot put infinity because x goes
two.
from the max. The upper limit of x is what? 3.
Yeah.
Yeah,
Yeah.
right? It is already given that the x lies between 0 to 3, but you are asked what? Greater than 2. So maximum value of x will be 3
Three.
because infinity represents what? Largest value of x, right?
Right. Right.
1 x cube over 3. So you can 2 cube, right? 3 cube is what? 27. 2 cube is what? 8. 19 over 27, right?
Yes. So it's not one, right?
It will not 1. It will always give less than 1. Why? Because you are not finding from 0 to 3. You are finding from 2 to 3.
Part of the okay.
Yes.
Okay.
This is 0 to 3, right? So from 0
Yeah.
to
Yeah.
3 is always 1. But you are finding from 0 to 3. It is always less than 1. Okay?
Makes sense.
Because you know the probability lies between 0 to 1. Maximum value will be 1 and minimum value will be 0. Right?
Yeah. Yeah.
Yes.
Now it's
What does effect tell about likely value of x? What does effect tell about the likely value of x? What is it? Yes. 19 over 27, right? Okay.
mm-hmm.
When you simplify this, 19 over 27, you will get what? 0.705. right?
I see. To represent like, yeah, okay, 70% of the area.
70%, almost 71%, you can say. So it means that out of 100%, 70% is covered by 2 to 3 range, right?
Mhm.
Okay. The graph of this is always live in this form. Why? Because in this form, because y is equal to what? 1 by 9 x square, and you know y is equal to ax square is always a parabola, right?
Yes.
And you are finding from 2 x is equal to 2 to x is equal to 3. So area of this part will be what? 0.7. Okay. When you find the
In that,
yes,
so for any continuous system, we need like first of all to have the description of the system as an equation.
yes,
Then after that we do the integration.
yes. Originally you are given this part 0 to 3, and when you the green part, the summation of all green part, not summation, the integration of all this part is 1, but
Yes.
the red part area is what? 0.70. 70% area is covered by red part. Okay. If I asked you what is the probability from 0 to 2, then you can say 1 minus 0.70, right? Yes.
Yes.
Understood?
Yes.
This is the significance of this. Okay. You can read this. Outcome outside 0, 3 are impossible. Why? Because the limit of x is given 0 to 3. Right?
Yeah.
Yes. Okay. First we see one more question. Okay. One more thing. Whenever continuous random variable is there, you cannot find the probability at that point. Okay. See, in continuous random variable, probability always you will always find probability in the form of range. If I ask you what is the probability of x is equal to a, it will always 0. Very important result. Not understood?
In a continuous probability, if we have x equal to a, then
0.
at a certain point.
Why? Because in continuous random variable, a continuous range is given always.
Mhm.
You cannot find the probability at that point. Why? Continuous is always given a range. This is not a range. This is a discrete value.
I see.
So for discrete value, the probability is always equal to 0. Okay.
Yes.
See this question. You are finding the probability from 2 to 9. Right?
Mhm.
In this case, no need to verify. Just find only its probability from 2 to 9. Sometimes verification is not asked. Okay. So how can you do this? Find probability from W 2 to 9. The range of W is what? 0 to 6, right?
Yeah, 0 to 6. Yes.
See
I
this
mean, like,
question. The range of W is what? 0 to 6. But you are asked to find what?
2 to 9.
2 to 9.
Okay, which exceeds the. Okay.
Yes.
So from 6 to 9, it's going to be 0.
0. Yes. So you can write. First we will
2
go
to 6.
from 2 to 6.
Yeah, right, yeah.
And from 6 to 9 it will be 0. Here it is given otherwise, right?
Yes.
DW. So from 2 to 6. Here we will like 2, 6. FW is what? 36 minus 144 DW, right? Okay. Okay. 144 is constant. Integration of 36 is 36W, W 3 over 3, right? So I can solve here. First we put 6. Then we put 2. Right?
Yeah.
36 into 6 is what? 216 minus 216 upon 3. 144. 144. Okay. And this is 22 minus into 208 over 3. You can simplify this, you will get answer, right?
Yeah.
Yes. Understood?
Yes.
See this question. The range of t is what? 0 to 1, right?
Mm-hmm.
But you are asked to find 0 to 1 by 4, right? 1
Which
4.
is just in one.
So you can write 0 to 1 over 4 ft dt. Okay. But if you calculate from 0 to 1, you will get always 1. Total is 1, right? It doesn't mean that you are finding 0 to 1 by 4 is 1/4. No, because the curve looks like this. This is larger area. This is smaller area, right? So 0 to 1 over 4, 3. 3 over 2 is constant. 3 raised to half 3t. 3 raised to half is half plus 1, 3 over 2, right? 3 over 2, 3 over 2 cancel. Okay, 1 over 8. 1 over 8 is the answer. When you solve using calculator, you will get 1 over 8. Okay. Now, uh, don't confuse with if the probability of 0 to 1 is 1, then it is not necessary that from 0 to 1 over 4 is 1 over 4, right? Because
Yeah,
yes, because it depends on function. Here
yes.
function is root t, and you know the graph of root t is what? Looks like this, right? Okay. So 0 to 1, this is 0 to 1. The area from 0 to 1 is 1, but area from 0 to 1 over 4 is 1 over 8. Okay, because this is smaller part, right? It depends on function. Here function is what? Parabolic function is there. Omega square. Omega square means its figure looks like this. Okay, from 2 to 6. This will be the area. Noted? This is important. Question number 19. Okay, first question is compute a number b. B is any constant. So that f is a PDF. Okay, you have to find the value of p so that fx is a PDF. You know, if fx is a PDF, then integration will be equal to 1, right? Okay,
Here we have like either greater than 2 or less than 2, right?
yes.
We don't have like the limits.
See, this is less than 2. It means that from minus infinity to 2, it is 0.
Mhm.
And this is greater than or equal to 2. It means from 2 to infinity it is, its sum is equal to what? Right? Yes. So this will be 0. No need to write. B is constant, so I can take outside. Right? Integration of x minus 3 is what? From 2 to infinity, right? Upon minus 2. You know 1 upon x minus 2 is what? 1 upon x square. 1 upon x square means when you put infinity, you will get 0. 1 upon infinity was 0.
1 upon infinity, yeah, 0.
Okay. 1 upon infinity square is always 0.
Identity, yeah.
Minus 1 over 4. So v over 8. So value of v will be 8. Right? It means that when you put b is equal to 8, it becomes a PDF.
Comes what?
It becomes a PDF. PDF.
PDF, okay, yeah, I see.
Yes.
Got it.
So for b is equal to 8, fx becomes a PDF. Okay.
Yeah,
Can we move?
yeah, please.
Okay. Now I tell you how to find expected value. What is expected value?
So the expected value, what I know is
Hmm.
the multiplication of probability by a variable, right?
Very good. But what does it mean? Okay. Whenever expected value, this is called expected value. It means average,
I see.
or you can say mean, right?
Mhm.
So suppose you are expecting 80 marks in your exam, let's suppose, right?
Mhm.
You are expecting what? 80 marks in your exam out of 100. It means that
Yes.
you are considering that you will get on an average 80 marks, right? Whenever you are saying I am expecting 80 marks, it means that on an average you are expecting 80 marks. So expected value means what? Average value. Yeah, or you can say mean value. Okay. Okay. So expected value is what? Summation x into px for discrete random variable. Okay. If the random variable is discrete, then you can find expected value by x into px. But if it's continuous random variable, then x into fx. Okay.
Integration of x. Okay. It's continuous.
Continuous random variable. Right?
Yeah.
One example I give you. Find the mean of fx 1 over 9. No need to verify, no need to do anything. Just find only the mean. Mean means what? You are finding expected value, right? Mean means what? Average value. And average value is denoted by expected value, right?
Yes, yeah.
Expected value is calculated by x into fx integration.
I see. I
So
see.
minus infinity is 0 and plus infinity is 3. X into fx. Fx is 1 over 9. 9 4 ja 9 9 ja. Okay. Expected value can be anything. It is negative, positive, greater than 1, greater than 2, greater than 3, anything.
Expected value is the mean,
Yes.
just x multiplied by the product of x. And if it's continuous, it's going to be the integration of x multiplied by f of
Yes.
x.
And let's see for discrete value how we find. Let's suppose this is discrete value, right? This is what discrete value, because only 4 discrete values are given.
Yeah, in the table.
Yes. See, this is discrete value because x is given only 4 values. Don't write in this way. X goes from 0 to 4. This is continuous. Okay. Continuous means x goes from 0 to 4. It is a continuous graph. But discrete is what? 0, 1, 2, 3, 4. Okay.
Point. Yeah.
I'm going to find the expected value of this PDF. So how can you find? You know, summation of x into px. X into ps. What is x? 0. And its probability is 1 by x, right? What is x? 1.
Mhm.
Its probability is, what is x2, right?
Yes.
Always
X
multiply its probability with its random variable and add all these.
Yeah.
Next, random variable is 3 and its probability is 1 over 8. So 0, 3 over 8,
Yes.
6 over 8,
6/8.
3 over 8, 6, 6, 12,
Which
12
is
over 8.
1.
So 3 over 2, 1.5. Okay,
I see. Mhm.
1.5 is the average value of this period, right?
And statistically, or well, another way, so the average of this function is 1.5, which means like it's going to be like the middle value of this distribution.
No, no, no. It means that on an average, you will get 1.5 number of head when you throw uh, 3 coins. Because this is what number of head.
Yes.
It means that on an average, you will get 1.5 times of number of head when you throw 3 coins. Okay.
Right. Yeah. Yeah. Because the
Out,
system here.
yes,
Yeah.
out of three, we are getting on an average 1.5. It means that 50% chance that you will get number of head. Understood? 1.5
Yes.
is what? 50% of 3.
Right.
So what is the significance of 1.5? It means that 1.5 number of, on an average, number of head will come when you throw 3 number of points. Okay. Understood?
Yes.
If expected value is 1.5 means on an average you are expecting 1.5 number of heads. Okay, 1.5 number of head means what? When you see in terms of probability, then you can say 50% chance that we will get number of heads, right?
Yes.
See this question. Fx is given. You have to compute Ex. Ex means find the mean. There are actually two questions in this part. First part is verify that this is a valid PDF. Valid PDF means first you have to check that its integration comes 1 or not. Okay.
Right.
So I skip this question because you understood this, right? I am computing this part. Okay. Okay. Ex is what? X into fx.
Right. Yeah.
One extra x is multiplied with fx, original fx. Okay. Into x. So 3 over 16 x into x raised to half. So you can write x raised to 3 by 2, right?
Yes.
When you add 1, you will get what? 5 by 2.
Yeah.
So 2, 8, 3 by 8 into 5, right?
Yeah.
Okay. Now put a, okay, 3 by 40, right? Okay. This is what? 4 raised to half raised to 5. Can you write in this way?
Yeah.
So 4 raised to half is
So
what?
the
2.
roots. Yeah. 2. Yeah.
And 2 raised to 5 is 32. 8 4 ja 8 5 ja 12 over 5, 2.4. Okay. So 2.4 is the answer.
Mm.
Understood?
Yeah.
You can go through one.
Yeah.
See this. Derivation is given. Derivation is not important. Okay. Okay. Next we see uniform distribution. Okay. Suppose, see, suppose you are taking from 1 to 10. Okay. And you want to distribute uniformly. Uniformly means at each step you are distributing each value. So how can you say if fx x goes from a to b, then the value of fx will be 1 upon b minus a. This is important.
One upon B minus A.
Yes, if x lies from 0 to b, sorry, a to b, remaining things otherwise. For example, if x lies from 0 to 2, what is PDF of uniform distribution? Uniform distribution is 1 upon 2 minus 0. Okay,
Mm.
right? So you can say 1 upon 2, 0. This is your answer. Clear?
Yeah.
Yes.
So if so, we have a function here, right? It's continuous.
Yes.
So if we would like to find the area or the should we do the integration for the function?
If the function is uniformly distribution, suppose in your company there are 10 members and you want to distribute uniformly, it means that you are distributing uh, equal price to each member, then you will follow uniform distribution. Okay.
That the confusion that I have now.
What?
What does it mean they have here? 1/2. Uh,
1 over 2 means what? 1 over 2, 1 over 2, 1 over 2, when you distribute it 10 times, or you can say from 0 to 2, you will get always 1. See,
from zero to two, I would get like almost half, right?
see, add 1 over 2, 1 over 2
Okay.
from 0 to 2. See, only one thing, if uniform distribution is given and from x a to b is given, its function will be 1 upon b minus a. That's it. Okay.
Okay.
This is called uniform distribution. From
I see.
a to b, each are uniformly distributed, right?
Mm.
Neither greater nor lesser on each step, right?
Yes.
And a is what? A is 2, b is 5. If I ask you what is the expected value of this, then you can say 1 over 5 minus 2, right? 1 over 3. This is what? fx. Mean will be, expected value will be x into fx
Right.
from 2 to 5. X into 1 over 3. So x into 1 over 3 is what? 3.5. Okay.
Yes.
3.5 is the average value. Right?
Yes.
Yes.
Yeah.
So tomorrow I will explain in with more example how to find expected value and what is the significance of uniform distribution.
Okay. Yeah.
So
Thank you.
basically there are four more topics: uniform distribution, exponential distribution, okay, Bernoulli
Yes.
distribution. So there are basically four distribution there, which are very important in analyzing data. Okay, when anything happens certainly accidentally, okay, then we use exponential distribution. Okay, let's suppose one thing was going very smoothly. One day it's suddenly increase in this way. So this graph represent what? Exponential graph. Okay, because exponential graph
Yes.
looks like this. So whenever anything happens certain accidentally or suddenly, then we use exponential distribution. When anything happens smoothly, continuously same thing is happening, then we use uniform distribution. Okay.
Okay. Yes.
And these are the part of continuous random variable. Okay.